How many of you have thought about future and sometimes fear that what it may bring? Maybe you can raise your hand. Yeah. So let me give you a context here. Here I am talking about future generation. With all this climate change, global warming, they are not just buzzwords. It's reality. And you can see their effects in your day-to-day life with all these natural disasters, heat waves, storms, and pollution. It's quite scary, isn't it? There is a published study by Climate Change and the World Resources Institute, which showed that annually more than 50 billion tons of greenhouse gases are emitted globally. If I say that if I assign 6 tons of that emission to each person living on the earth, still it's less. And there are various sectors responsible for this massive number. But as a structural engineer, I'll focus on construction industry, where over 10% is caused by materials like cement, steel. And let me give you a silent culprit here, crop burning, which is leading towards 3.5% of emission. Now you must be thinking, if we know that it may cause pollution, why do we burn it? So it's a quite common practice followed worldwide, where farmers are tend to burn their agricultural waste for the next crop cycle. It's easiest and cheapest way, leading towards carbon emission. Whether it's legal or illegal, that could be another point of discussion. And now you must be thinking, why this person is telling us all this data and scaring us, right? But let me tell you, there is a hope where a single solution can help with reducing all this emission, and that is biocomposite structures. Let me tell you a story about me. Now it has been over 6 years since I am living in Delhi. And in early days of my PhD, I started working on fiber reinforced polymer composite structure. I was very excited about the topic because it was quite new for me for civil infrastructure. And then first winter came. The sky turned gray. It was difficult to breathe. You could literally see the smoke in the air. And schools, colleges, everything got closed. At that time also, my research was going well, but my lungs not so well. And at that moment, we realized that we need a solution for this. This is a solution which is more sustainable and local. And that came in form of biocomposite structures made of agricultural waste. Or rather, I prefer to call them agricultural treasure. The most commonly used or generated agricultural waste are based on fibers like wheat, rice, sugarcane. And there could be another natural fibers like jute, coconut, or bamboo, banana. I think you must be seeing these all plants in your day-to-day life around you. Now you must be curious that, okay, we can imagine the plants. Now how to make biocomposites out of it? So let me give you a little bit brief background. In this process, first we collect this agricultural waste or these natural fibers from the field. We cut them in form of straw or long fibers depending on the biocomposites. And we clean them, we provide certain treatments so that the impurities or some unrequired components like lignin, silica can be removed from it. It's as simple as cleaning and cooking your vegetables. Just don't put spices in it. And the beauty of this processing method is whatever bioproducts are generated, like I'll give you for example, Whenever we clean them and we treat them, there is a black liquid generated, which is called black liquor, that can be further utilized for biofuel generation. So the entire system follows the no waste policy. And further, after cleaning those fibers, we dry them, we mix them with the binder. The binders could be anything, they could be based on the bio-based resin or cementitious material, lime-based material, or some polymeric materials. And further, we give it a particular shape as per our application requirement, and you are good to go. So now you must be thinking the entire process is so simple, but there are so many important parameters in it. For example, what pressure, what temperature to apply, which fibers to choose, which binder to choose, in what ratio they should be mixed. So for these all important parameters, we researchers come into pictures, where we can design these biocomposite as per the application requirement, whether it's high load bearing biocomposite or non-structural just for the architectural purpose. So let me give you example of some of the biocomposite applications where they can be used for the flooring, roofing, or insulation board. In this hall also you will be seeing around you, there are so many panels. Biocomposites could be alternative to all these panels. And some of my favorite applications. On slide you must be seeing some steel shelter or some guard cabin or bus stand. These all structure we see around in our day-to-day life. And the thing about the steel structures are, they stay warmer in summer and they stay cooler in winter. And I can't even imagine how much uncomfortable it is for the person who is sitting 24 hours in that. So these biocomposites could be an alternative to such applications. They have various advantages, like because they are lightweight, which reduce down the structural load. If I use these biocomposite in designing my building, because the structural loads are reduced, the structural inertia has been reduced, in earthquake they will perform better. And because their weight is less, it's easy to transport them. They could be a good option for the applications at complex geographical locations, where it's not easy to carry the conventional construction materials like concrete, steel. So this could be an alternative for that as well. And unlike conventional construction materials, they are less carbon intensive, helping with the reducing the emission due to construction materials. And they have very good high thermal insulation properties. So let's say if I use this biocomposite in our buildings, it will require less artificial heating and cooling, helping with another energy related consumption by buildings. We have conducted a study at IIT Delhi where we found out that instead of going towards path of stubble burning, if we choose path of production of biocomposite, it can help in reducing the emission by more than 50%, further helping with the emission by crop burning. And currently there are many countries, they are struggling with agricultural waste management. They are developing different guidelines, standards. So this could be one of the solution. While construction industry, they are disposing their solid waste in landfills, water bodies. If this could be an alternative to such construction materials, it will further help with such pollutions. And it's not only about reducing our air pollution, it's also about rethinking the waste which is generated around us. It's also about promoting the concept of reduce, reuse, and recycle. And because of their biodegradable nature, they follow the circular solution, which starts from the land and ends up in the land, and helping sustainable development goals. Further advantages with such biocomposites are because they are taken from the farms, it gives additional values to farmers, it gives additional value to local vendors. And I remember there are so many tribes, they are making their living out of extracting these fibers from the plants. So it gives values to those people, it creates employment. And here we are majorly tackling three major challenges: crop burning, construction materials, and solid waste disposal. So this is one of the solution for that. Let me paint a picture for you where you imagine one side there is a village, one side there is a city. By the way, how many of you see this kind of houses around you nowadays? Not anymore, right? Well, these houses were made of natural materials. And in villages, you have comparatively fresh air. Whereas on the city buildings, you all see concrete, steel, and with all these heat waves, it's difficult to live in that, and air pollution. So the thinking is that is there possibility to have a common ground? And that common ground could be biocomposite structures, where we can have better thermal insulated houses. We can have better fresh air. We don't need to burn our crops. We can utilize them for making such houses. And these biocomposite structures could be a very strong bridge between village life and city life, between affordability and innovation, between tradition and sustainable progress. So in few years, if you see a multi-story structure standing made of biocomposites, so don't be surprised, because I am sure we will get you there. Thank you.